Certainly, I'll expand on the concept of hard eliminative information theory within a strict physicalist framework. Here's an extended exploration of this topic: hard eliminative information theory. Rooted in a strict physicalist framework, presents a radical perspective on the nature of information and its place in our understanding of the universe. This theory posits that information, as commonly conceived, is not a fundamental or meaningful entity distinct from physical processes. Instead, it argues that all phenomena typically described as informational are, in reality, nothing more than physical processes devoid of any inherent informational content or meaning. One reduction to physical processes at the core of hard eliminative information theory is the assertion that all phenomena, including those conventionally labeled as informational, can be fully explained by physical processes and properties alone. This view contends that what we typically describe as the transmission, storage, or processing of information is, in fact, nothing more than the movement, interaction, and transformation of physical entities. For example, consider the transmission of data over the internet. In conventional terms, we might describe this as the transfer of information from one point to another. However, from the perspective of hard eliminative information theory, this process is reducible to the physical movement and interaction of electrons in wires or photons in fiber optic cables. The theory argues that there is no need to invoke the concept of information to explain what is happening. The physical description is both necessary and sufficient. Similarly, the storage of data on a hard drive is not seen as the preservation of abstract information, but rather as the specific arrangement of magnetic domains on a physical medium. The retrieval of this data is simply the process of detecting and interpreting these physical states without any need for an additional layer of information to explain the phenomenon. To denial of dualism, hard eliminative information theory takes a strong stance against any form of dualism, the philosophical idea that there are two fundamental types of substance or reality. In the context of information theory, this dualism might manifest as the belief that there exists both a physical realm and an informational realm, or that information is somehow a property or entity distinct from physical reality. Instead, this theory posits that everything in the universe, including what we perceive or describe as information, is composed solely of physical matter and energy governed by the laws of physics. There is no separate domain or layer of reality that can be called informational. All phenomena, no matter how complex or abstract they may seem, are ultimately reducible to physical states and interactions. This rejection of dualism extends to cognitive processes as well. From this perspective, thoughts, memories, and cognitive computations are not manipulations of abstract information, but rather specific patterns of neural activity, which are themselves physical processes involving the movement of ions, the release of neurotransmitters, and the activation of synapses. 3. Elimination of abstract entities. A key tenet of hard eliminative information theory is the rejection of abstract entities or concepts as having any independent existence or explanatory power. In conventional information theory and many areas of cognitive science, information is often treated as an abstract concept, something that can be quantified, manipulated, and transferred independently of its physical substrate. However, hard eliminative information theory argues that such abstraction is not only unnecessary but also misleading. It contends that everything can and should be described in terms of concrete physical states and interactions without resorting to abstract notions like information, meaning, or representation. For instance, what we typically call a bit of information, often conceptualized as an abstract unit that can be either 0 or 1, is, in this view, nothing more than a specific physical state. The theory argues that there is no need to posit an additional layer of abstraction beyond this physical description. For empirical inadequacy of information as a separate entity, proponents of hard eliminative information theory argue that the concept of information as something over and above physical processes lacks empirical support. They contend that all experiments and observations that purportedly deal with information are actually dealing with quantifiable, observable physical phenomena. For example, in information theory, the concept of channel capacity is often used to describe the maximum rate at which information can be transmitted over a communication channel. However, from the perspective of hard eliminative information theory, what's actually being measured and described are physical properties of the channel, such as bandwidth, signal-to-noise ratio, and the behavior of electrons or photons in the transmission medium. The theory argues that invoking information as an additional entity or property adds nothing to our understanding or ability to predict and control these physical processes. Similarly, in cognitive neuroscience, experiments that claim to measure information processing in the brain are, according to this view, simply measuring patterns of neural activity, blood flow, or other physical properties of the brain. The concept of information itself is seen as superfluous to explaining these observations. 5. Philosophical parsimony. Hard eliminative information theory appeals to the principle of parsimony, also known as Occam's razor, which suggests that among competing hypotheses, the one with the fewest assumptions should be selected. By eliminating the assumption of an information layer existing alongside or within physical processes, this theory claims to provide a more parsimonious explanation of observed phenomena. From this perspective, positing the existence of information as a separate entity or property introduces unnecessary complexity into our understanding of the world. If all observed phenomena can be explained solely in terms of physical processes and properties, then adding an additional layer of information violates the principle of parsimony. Proponents argue that this approach not only simplifies our ontology but also provides a more coherent and unified framework for understanding the world, as it doesn't require us to explain how abstract information interacts with or emerges from physical processes. 6. Implications for cognitive science and artificial intelligence. The adoption of hard eliminative information theory has profound implications for fields such as cognitive science and artificial intelligence. In cognitive science, it challenges many of the foundational assumptions about how the mind works. Instead of viewing cognition as the manipulation of abstract symbols or information, it suggests that we should understand mental processes purely in terms of neurobiological mechanisms. For artificial intelligence, this perspective suggests that the goal should not be to create systems that process abstract information, but rather to create physical systems that exhibit desired behaviors. The focus shifts from abstract algorithms and representations to the specific physical implementations that produce intelligent-seeming behavior. 7. Challenges to conventional notions of meaning and semantics. Hard eliminative information theory poses significant challenges to traditional notions of meaning and semantics. In conventional understanding, information is often thought to carry meaning or semantic content. However, this theory argues that meaning and semantics, like information itself, are not fundamental features of reality but rather human constructs that can be fully explained in terms of physical processes. From this perspective, what we perceive as the meaning of a sentence, for example, is not an abstract property of the words or the information they convey, but rather the physical effects that hearing or reading those words has on our brains. Semantic content is reduced to causal relationships between physical states. A reinterpretation of communication processes under hard eliminative information theory. Communication processes are reinterpreted entirely in physical terms. What we conventionally describe as the exchange of information between individuals is seen as nothing more than a chain of physical cause and effect. For instance, in verbal communication, this view would describe the process as follows: physical vibrations in the air cause physical changes in the listener's ear, which in turn cause specific patterns of neural activity in their brain, potentially leading to changes in their behavior. At no point in this process, according to the theory, is there a need to invoke the concept of information transmission. 9 implications for information technology. The adoption of hard eliminative information theory would necessitate a fundamental reframing of how we think about and describe information technology. Instead of talking about data storage, information processing, or data transmission, we would need to describe these technologies purely in terms of their physical operations. For example, computer programming would be reframed not as the creation of abstract algorithms, but as the design of specific physical states and transitions in electronic circuits. Database management would be described in terms of the organization and manipulation of physical storage media, rather than the storage and retrieval of abstract information. 10 philosophical and practical challenges. While hard eliminative information theory presents a logically consistent and parsimonious worldview, it faces significant philosophical and practical challenges. One major challenge is that it seems to conflict strongly with our intuitive understanding of the world and our subjective experience of things like meaning, knowledge, and understanding. Moreover, even if one accepts the theoretical validity of this view, it may be impractical or unhelpful in many real-world contexts. The language of information and meaning is deeply ingrained in how we think about and interact with the world, and it often provides useful shorthand for describing complex phenomena. Abandoning this language entirely in favor of purely physical descriptions could make communication and problem-solving much more cumbersome in many fields. 11. Relationship to other philosophical positions. Hard eliminative information theory shares some similarities with other philosophical positions, such as eliminative materialism in philosophy of mind. Eliminative materialism argues that our common sense understanding of the mind, including concepts like beliefs, desires, and emotions, will eventually be replaced by a purely neurobiological account. Similarly, hard eliminative information theory can be seen as extending this eliminativist approach to the domain of information. It suggests that our common sense notions of information, meaning, and representation will ultimately be replaced by a purely physical account of the world. 12. Potential impact on scientific practice if widely adopted. Hard eliminative information theory could have significant implications for scientific practice across various fields. It would require researchers to reframe their hypotheses, methodologies, and interpretations in purely physical terms, avoiding references to information or other abstract entities. For example, in neuroscience, instead of studying how the brain processes information, researchers would focus solely on mapping and understanding the physical changes and interactions within neural networks. In computer science, the emphasis would shift from abstract algorithms and data structures to the specific physical implementations of computational processes. 13 challenges in education and public understanding. The adoption of hard eliminative information theory would pose significant challenges in education and public understanding of science and technology. Much of our current approach to teaching these subjects relies heavily on concepts of information, data, and abstract representations, framing these fields entirely in terms of physical processes. while potentially more accurate from this philosophical standpoint, could make them less accessible and more difficult to understand for many people. This could have implications for scientific literacy and technological adoption in society. 14. Ethical and social implications. The philosophical stance of hard eliminative information theory also raises interesting ethical and social questions. If all phenomena, including human thoughts and behaviors, are reducible to physical processes, what does this mean for concepts like free will, moral responsibility, or human rights? Moreover, if meaning and semantics are not fundamental features of reality but merely human constructs, how does this affect our understanding of language, culture, and social interactions? These questions highlight the potentially far-reaching implications of this philosophical position beyond just the technical domains of information theory and cognitive science.